Okay, for this next example, what we're going to do is we're going to see how the inverse trig function plays in a word problem. Now, again, with this particular word problem, the visual or the picture has been drawn for you. What I'm going to suggest to you is that you get comfortable drawing your own picture and understanding what's taking place. Ultimately, what you're trying to do in this picture, however, is to create your own triangle, which they've created here. Then you can just simplify this by creating your own trig problem. Now, keep in mind that this +5, this 5 feet off the ground, that's an important part of the problem when you're looking for how long that arm should be. So keep that in mind, because of that 130 degrees, 130 feet, 5 of it, the arm is sitting off the ground. So you have to take that into an account. And you can see in the solution here, when we create the triangle, instead of using 130, we actually use 125 for that particular side length whenever we use sine. And of course, once it's set up, you can see that the inverse trig function's used all the same. And it's a pretty straightforward problem. So really the skill here is just getting comfortable with what the word problem is asking you to do. So in sample problem 3, we've given you a similar problem, but we haven't given you the picture. We want you to draw the picture first and get in the habit of doing that. So go ahead and take a little bit of time to read the problem, draw the picture, set it up, and solve it, and come back and check your answer. Okay, so you can see here I've taken the time to draw the picture. It said the crane whose lower end is 4 feet off the ground has an arm of 100 feet. So I've created those two parts. The arm has to reach the top of a building that's 80 feet high. At what angle should the arm be set? So the triangle actually needs to be set in relation to the arm, which is this part right here. So in that particular regard, our opposite part of our triangle is actually just going to be 76 instead of the 80. So we're going to get this particular triangle right here. And so we can see that in relation to the angle that the arm is making with the ground, we have an opposite, and then we have a hypotenuse in relation to the angle theta. So I'm going to use sine here. And then we're going to use the inverse function to get the answer for that. And you could reduce the 76 over 100, but it's really not necessary to do that, since your calculator will take it all the same. And then that approximates to 49.5% degrees, excuse me. Now, that being said, notice in the problem there were no directions as to what to round to. So if we have a decimal angle, we'll just go ahead and round it to the nearest tenth. If it says to round to the nearest degree, that's fine. Now, as you move along in trig, so next year when you get into advanced math, instead of having decimals, what you'll then learn is that degrees can actually be broken down into smaller parts called minutes and seconds. And so then you'll start taking that decimal part of the answer and breaking it down into actually fractional parts of the degree. So, but you'll learn a little bit more about that in advanced math. Right now, we'll just take the decimal 49.5.